This example looks production-ready at first glance, but it's missing the one critical piece that makes it actually secure for real deployments. We'll walk through exactly what this GitHub OAuth setup does with Redis storage, why it's incomplete for production use, and the mandatory encryption layer you must add. You'll see how environment variables feed into the provider, how Redis enables multi-server token sharing, and where the Fernet encryption wrapper becomes non-negotiable for security compliance. Import auth. From FastMCP, server, auth providers, GitHub import GitHub provider. From key value, AO stores, Redis import Redis store. Auth equals GitHub provider. Client ID equals OS. Environ GitHub client ID. Client secret equals OS. Environ GitHub client secret. Base URL equals https://yourserver.com. JWT signing key equals OS. Environ JWT signing key. Client storage equals Redis store. Host equals Redis. Example, com, port equals 6379. This demonstrates the storage backend composition pattern with explicit security requirements, where authentication provides delegate storage to pluggable backends while enforcing encryption for production use. The example shows GitHub OAuth configured with Redis storage, but the official documentation mandates wrapping any production storage in Fernet encryption wrapper to encrypt tokens at rest. This pattern separates storage implementation from authentication logic, while enforcing security constraints at configuration time. The approach works through declarative composition, where you configure both storage and encryption when initializing providers. All backends implement the same key-value interface, but production deployments require explicit encryption wrapping. Redis store alone would store tokens in plaintext. The framework uses environment variables for secrets, GitHub client ID, JWT signing key, storage encryption key, following 12-factor principles, with the base URL parameter handling OAuth redirect flow. This pattern solves the challenge of secure credential storage across different deployment scenarios. Development can use simple in-memory storage, while production requires encrypted Redis or disk storage through configuration changes only. The trade-off is mandatory encryption setup, but this prevents security vulnerabilities while maintaining clean separation between authentication logic and infrastructure. The official documentation emphasizes this is a composition time security requirement, not an optional enhancement. Let's break it down line by line. Import auth. This imports auth to access environment variables, following 12-factor app principles for credential management. The pattern keeps secrets like GitHub client ID and JWT signing key out of source code. But note this example is development only. Production requires wrapping storage backends in Fernet encryption wrapper to encrypt tokens at rest. Always source encryption keys from environment variables, never hardcode them. From FastMCP, server, auth providers, GitHub import GitHub provider. This imports GitHub provider, FastMCP's OAuth 2 authentication handler that manages GitHub login flows, token exchange, and user validation. Warning: this example shows a development-only configuration. It stores tokens in plaintext Redis, violating security requirements. For production, you must wrap Redis store in Fernet encryption wrapper using a key from environment variables, as shown in the official docs. The storage backend implements a common interface, allowing swaps between Redis store, disk store, or others, but encryption is mandatory regardless of backend. The base URL parameter configures OAuth redirect endpoints, while cliented and client secret follow 12-factor principles by loading from environment variables. From key value, AO stores, Redis import Redis store. This imports Redis store and a sync Redis backend for session storage, but this configuration is incomplete for production. Without Fernet encryption wrapper, OAuth tokens would be stored in plaintext, violating security requirements. For production use, you must wrap it as Fernet encryption wrapper, key value equals Redis store, Fernet equals Fernet OS, environ storage encryption key. This example shows only the development pattern. Real deployments require the encryption layer and a storage encryption key environment variable.
Auth equals GitHub provider.
This instantiates GitHub provider for OAuth authentication, but this configuration is development only. It stores tokens in plaintext. For production, you must wrap Redis store in Fernet encryption wrapper to encrypt tokens at rest, using a storage encryption key from environment variables. The provider handles the full OAuth flow, redirects, token exchange, and JWT issuance, while delegating session storage to Redis store, which requires the PyKey valuarities extra. The base URL parameter defines your server's OAuth callback endpoint, critical for proper redirect handling.
Client ID equals OS. Environ GitHub client ID.
This pulls the GitHub OAuth client ID from environment variables, following 12-factor app principles. Warning: this example shows a development-only configuration that stores tokens in plaintext. Never use this in production. For production, you must wrap Redis store in Fernet encryption wrapper from key value, AO, encryption, with the encryption key loaded from storage encryption key in environment variables. The official docs mandate this pattern to prevent token exposure.
Client secret equals OS. Environ GitHub client secret.
This loads the GitHub OAuth client secret from environment variables, following 12-factor app principles. Warning: this example is incomplete for production. It stores tokens in plaintext. For production use, you must wrap Redis store with Fernet encryption wrapper. Python: client storage equals Fernet encryption wrapper. Key value equals Redis store, host equals Redis. Example: com, port equals 6379. Fernet equals Fernet, OS, environ storage encryption key. The encryption key must also come from environment variables. Never use plain Redis store in production. It violates security requirements.
Base URL equals https://yourserver.com.
Sets the OAuth callback base URL required for GitHub's redirect flow. This must exactly match your GitHub OAuth application settings, otherwise authentication fails with redirect URI mismatches. Warning: this example shows a development-only configuration. For production, you must wrap Redis store in Fernet encryption wrapper to prevent storing tokens in plaintext. The official docs mandate encryption for all production storage backends.
JWT signing key equals OS. Environ JWT signing key.
This JWT signing key from environment variables enables secure token generation, but this example is incomplete for production. Without Fernet encryption wrapper, Redis would store OAuth tokens in plaintext, violating security requirements. For production, you must wrap Redis store. Python: client storage equals Fernet encryption wrapper. Key value equals Redis store, host equals Redis. Example: com, port equals 6379. Fernet equals Fernet, OS, environ storage encryption key. The encryption key must also come from environment variables, and the wrapper is mandatory per official docs. Never use plain Redis store in production.
Client storage equals Redis store, host equals Redis. Example: com, port equals 6379.
This configures Redis as the OAuth client storage backend, but this example is incomplete for production. The official docs mandate wrapping Redis store in Fernet encryption wrapper with a storage encryption key from environment variables to prevent plaintext token storage. The pattern supports swappable backends, Redis for distributed systems, disk store for local testing, but requires explicit encryption via Fernet encryption wrapper. Key value equals Redis store, Fernet equals Fernet, before production use. The shown code would store tokens insecurely without this wrapper. This closing parenthesis finalizes an incomplete GitHub provider configuration that would store OAuth tokens in plaintext. This example is development only. Production requires wrapping Redis store in Fernet encryption wrapper to encrypt tokens at rest. The pattern composes storage at instantiation time, but the shown code violates security requirements from the official docs. For production, you must add the encryption layer and provide storage encryption key via environment variables. Secure OAuth storage pattern. FastMCP's GitHub provider delegates token persistence to Redis store for distributed capability, but production security mandates wrapping storage in Fernet encryption wrapper to encrypt tokens at rest. The shown configuration stores tokens in plaintext and must never be used in production without adding the encryption layer from the official documentation. Redis support requires installing PyKey value arrays, and all sensitive values, including storage encryption key, must come from environment variables following 12-factor principles.
The distributed system that shares everything must first conceal everything it shares.